Hi there, my name is Demis Haralambidis, and in this video we'll talk about and we will basically define what probability of an event really is. And then once we do that, we will work together some examples. Let's begin with the things that we should know by now. First of all, in one of our previous video lessons, we defined the probability experiment, and we defined it as a process which is either conducted by us or observed, which has a key characteristic. We don't know what will happen in advance. For example, when we throw a die, when we pick a card from a deck of cards, when we are waiting in the bus and we care about the arrival time of the bus, and so on. One thing is certain though, something will happen, and that something is called outcome. And what do we get if we create sets of one or more outcomes? We get what we have defined as event. So let's stick to that. Let's assume that we have an event A. So let A be an event. Probability of A, which is notated by P of A, is defined as the ratio of the cardinality of A over the cardinality of the universal set. So if we want to translate that verbally, we would say that it is the amount of outcomes that satisfy A over the total outcomes. Always the amount of total outcomes of a probability experiment. So once again, the probability of an event is defined as the amount of outcomes that would satisfy that event over the amount of all possible outcomes of the specific probability experiment we are working with. These are called cardinalities. So in more simple words, probability of A is equal to the cardinality of A over the cardinality of the universal set. Let's work together now some examples. We have the examples at the left. Let's begin with exercise 1. A fair 6-sided die is rolled. Find the probability of rolling a 3. First of all, we should always begin by finding the universal set. And that is exactly why we spent a whole video, one of my previous videos, on working on that exact thing, finding the universal set. Here we know that our probability experiment will be that of rolling a die. So the universal set, which is once again the set that includes all possible outcomes, is each one of the faces that we can get. So the universal set is the set containing the faces 1, 2, 3, 4, 5, and 6. Since we will be working with cardinalities, we need its cardinality as well. Obviously, n of u is 6. Now, let's focus to our event. In exercise 1, we need to find the probability of rolling a 3. So we can define our event A as exactly that, rolling a 3. How many of the universal sets outcomes are there in A? It's just number 3. So what is the cardinality of the event A? Is just 1. Hence, the probability of A would be 1 out of 6, which I assume that it should make perfect sense. Let's move to exercise 3. A standard deck of 52 cards is shuffled and one card is drawn at random. Find the probability of drawing a heart. So let's figure out the probability experiment first. It is us drawing a card from a deck of 52 cards. What should the universal set be? In other words, what are all possible outcomes that I can get? When I pick a card, I could actually pick each one of these 52 cards of the deck. So the universal set would have been each card in the deck. In terms of numbers, we would expect to have a cardinality of 52. Now, let's define set A. We need the probability of drawing a heart. So that's exactly my event A, drawing a heart. In terms of numbers, how many cards will there be in A? Exactly as many as the number of cards with hearts, which is 13. So we expect, for instance, to have the heart ace, heart 2, heart 3, up to the heart kings. And in total, these are 13 different cards. So the probability of A is 13 out of 52, which is equal to 1/4. Exercise 4. 2 fair 6-sided dice are rolled. Find the probability of getting a sum of 7. I know what it says. So let's begin by the universal set. We should know that the universal set when rolling 2 dice is every possible combination of these 2 dice. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, and 6, and finally 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. In total, we have 36 different combinations. So the cardinality of the universal set is 36. Now, to define event A, we need to get a sum of 7. Sum of 7. We will then search through the outcomes in the universal set and mark down all these that actually create a sum of 7. It would be this: 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1, which we will write that here: 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1, which has a cardinality of 6. So finally, probability of that is 6 out of 36, which is 1/6. Let's move then to 7. A fair coin is flipped twice. So let's create the universal set. We know that when we flip a coin 2 times, then the universal set contains all possible pairs. So we would have tails and heads, tails and tails, heads and tails, heads and heads. Now, we need to get exactly 2 tails. So 2 tails. In terms of items, we would have just TNT. In terms of cardinalities, N of U is 4, N of A is 1. So finally, probability of A is 1/4. Then let's move to exercise 12. We have a fair coin, which is flipped 3 times. Find the probability of getting 2 heads and 1 tail. First of all, let's create the universal set. We can do that through a tree diagram. In the first flip, we can have tails or heads. In the second flip, no matter of what happened in the first one, we can still get tails or heads, tails or heads. In the third flip, no matter of what happened in the two previous ones, we can have tails, heads, tails, heads, tails, heads for each case. In the end, the universal set will contain each one of these branches. For instance, one branch would have been this, another branch would have been that, a third one would have been this, a fourth one would have been that, and so on. Now, let me write down all possible combinations. Tails, 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 heads, tails, heads, tails, tails, heads and heads, heads, tails, tails, heads, tails, heads, 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 tails, and heads, heads, heads. We can obviously see that we have a cardinality of 8. And now let's focus on defining the set, the event A. The event A would be 2 tails and 1 heads. I guess it was the opposite, but it's still fine. It's still under the same concept. 2 tails and 1 head. We should search through our universal set. How many of these 8 possible outcomes satisfy that? 2 tails and 1 head. We have this. We have that. We also have this. It's just these 3. So in terms of items, we would write T, T, H, tails, heads, tails, heads, tails, tails. And in terms of cardinality, it would be 3, which would make the needed probability equal to 3/8. What else? Now, let's see. A fair coin is flipped 4 times. No, let's do one with... Let's do number 6. A bag contains 4 green marbles. So let's do 4 green, 6 yellow. 6 yellow marbles. We pick one randomly. Find the probability of drawing a yellow marble. First of all, let's create the universal set. When we pick one marble randomly, what are the possible outcomes? Don't rush. Don't think it will either be yellow or green, because we don't care just for the color. We care for the marble. So since we have 4 green marbles and 6 yellow marbles, in the end, there are 10 different marbles that we can get. So assume that these marbles had numbers on them. So it could have been green 1, green 2, green 3, and green 4, or yellow 1, yellow 2, yellow 3, yellow 4, yellow 5, and yellow 6. This creates a universal set of 10. Now, regarding our event, we need to draw a yellow. In terms of items, this would have been yellow 1, yellow 2, yellow 3, yellow 4, yellow 5, yellow 6, which creates a cardinality of 6, which finally means that the probability of that event of drawing a yellow marble is 6 out of 10. And that was all. Remember that the essential part in finding the probability of an event is, first of all, realizing what the probability experiment is and calculating the cardinality of the universal set and the universal set itself, because through the universal set, we will be searching to find how many of these outcomes satisfy what we need. Finally, once we do that, the probability of an experiment, you will realize that it is just one simple division. That was all from me for now. For any question that you might have, you can always leave your comment below the video. As always, thank you for your time.